Today we're going to be talking about entity classes. These are a part of the Java Persistence API, and we'll be looking at how we can use these in the context of our Java Enterprise applications. We looked at session beans last week, and this time when we look at these, I want you to think about how they can then be used from a session bean. First thing we need to talk about just briefly is the concept of annotations. You're probably quite familiar with these already. The idea of an annotation is that it is a Java modifier that is prefixed with the @ sign. We'll find, for example, in a stateless session bean, the annotation @stateless. Now, the EJB3 specification is a subset of the Java Enterprise Editions specification, and it provides annotations for that list on screen. We've already seen some annotations for beans, and we'll see some other annotations as well. Last week we also talked about some transaction annotations. Now, the interesting thing about annotations is that they're not just used for labeling to say, oh, this is a stateless something or other. It's also used for generating artifacts. In other words, we can, through the use of annotations, automatically inject some resources into our classes. Just by the name, which is a well-chosen name for these annotations, we can document the code. So it's very easy with that annotation to see, oh, this is a stateless session bean. It also enables us to tap in very easily with just one simple annotation into various services such as security or runtime specific logic. And we're going to see today an example of using one simple annotation to tap into the Java persistence unit. Now, I mentioned a moment ago dependency injection. As I've mentioned in a previous lecture, this is possible through the contexts and dependency injection framework. What it allows us to do then is to link the web tier with the business tier through the use of annotations, and it helps us to integrate various components without a very tight coupling. Now, the really nice thing about this is that the CDI will do this automatically, so that when you instantiate a bean, or rather when you cause a bean to be instantiated, then the CDI will automatically look at all those annotations and those resources that the annotations refer to and bring those in without you having explicitly to do anything about that. As long as your code has the annotation in front of a variable name, for example, then it will automatically create an instance or use an existing instance of that thing, that resource, and make it available in your program. And because of that, the CDI is going to manage the lifecycle of those various resources and their dependencies. To make use of a resource, especially an external resource, we're going to need the gdm that we talked about at the end of the last lecture, so that we're naming and we're maintaining a directory of resources. We give them a name, and by using that name within our application, along with that annotation, it will tell the framework to go off and find that resource with that name, and then load it into and make it available to your class. So some of the resources that can be injected will include things like the session context object, data sources, entity manager. Now, that's going to be a useful one in the context of today's discussion. The entity manager is the thing that allows us to manage the various instances or objects of entity classes, and other things that you can see listed on screen there. And so here we have at the bottom of the screen an example of such an annotation. @resource, there's the annotation, in front of the declaration of a message-driven context reference. So what the runtime environment will do is go and find a resource of that particular type, and then will make this reference point to that object that it has found. Now, the Java Persistence API was introduced by the Java EE platform, and it allows us to interact with databases without having to worry about what exactly the database logic is. We don't need to worry too much about the database structure. Once we've set up a persistence unit, we will be able to use the entities that come out of that persistence unit as objects, and those objects will be linked to database tables, but we can use them in our code as if they were objects, And the persistence API with that entity manager that I just mentioned will automatically keep the database and those entity objects in synchronization. Talk a little bit more about that as we go on. Now, when you're using the JPA, one of the things that you've got to use is an entity class. This is a plain old Java object, and each object will be attached or represent a specific row in the table. As you'll see in a bit, it doesn't actually have to be attached to that row. There are times when it won't be, but it will represent a row in a table in the database. We're also able to make use of this outside of the Java EE platform. So just because I'm introducing it to you today in the context of Java EE, don't go away with the idea that it's limited only to Java EE. You can use this API from any of your Java environments. What it provides for us is a standardized object relational mapping. Now, this is very useful. Think about how you've had to do it before now. You know that you've got a relational database. You have to work out how to connect to that database. That means you've got to go and find some JDBC classes. You have to know which of those classes you've got to invoke as the driver manager. You've then got to connect to the database and then use some prepared statements and SQL commands and all the rest of it, getting result sets, processing the result set, and so on. You've had to do all of that, in a way, the hard way. Using the Java Persistence API will make all of that interaction transparent to your Java code. All you've got to do is to make available to your class a resource, a persistence unit resource, and then just use it. All the connections to the database and so on, that's all hidden away, that's transparent to your code. So it provides this standardized mapping, and it means that you can use objects that represent table data, but not worry about whether they're actually table data or not. You can use those objects, and the persistence manager, which is part of the JPA, will just take care of the synchronization with the database. We'll still need some queries. We can use native queries if we want to. So we know already that SQL commands for one kind of relational database will not necessarily be precisely the same as the equivalent in another database management system. We don't need to worry too much about that if we use a JPA query, because that is portable. But if we use a native query, that is less portable, whereas a JPA query, being entirely portable, will always work. And we've got an example at the bottom here of a JPA query. It's a named query, hence the annotation @named. And within that set of brackets, we have two attributes. Name, and that's the name by which it will be known within the Java environment, and so we can do a search for that query using that name. And then the other attribute is query, and that contains, well, it looks like SQL, doesn't it? It's very similar to SQL, which you'd expect, and it uses named parameters. You can see that the way the named parameter is introduced is with a colon. As you do the tutorial work, you will see how those are used. Now, these entities can be attached to a database table or a row in the table. They can also be detached. If they are detached, then they are not linked to the table. Therefore, synchronization between that entity and the table will not occur. And that means that it's safe to send them around the system to other components. Not all components should have access to them when they are attached, but when they are detached, it's okay to send them around. But to do that, especially if you're sending them from one computer to another because of your distributed architecture, you will need to make sure that they are serialized. So they would implement the java.io.serializable interface. If you're going to use that mechanism, then there's no need to set up data transfer objects. These, once detached, essentially become the data transfer object. The entity manager that I've already mentioned a little bit, that is, as we've said before, a standard API, and it allows us to perform the CRUD operations on entities within the database. So we can create them, query them with a read, update them, delete them. So the persistence unit has to be there. It won't work otherwise. Amongst other things, we will have to set up that persistence unit before we start using it within our code. So there's some operations to perform outside of the code to set up the persistence unit, make that persistence unit available to the project, and then we can use the annotations to obtain a reference to that persistence unit. Now, the persistence unit is a collection of properties that determine how the entities are managed. We can also indicate which entity classes are going to be within the scope of management for this persistence unit. So your database might have many tables, but you're only interested in your particular application in managing a few of those tables. And so we'll identify within the persistence unit properties which of those tables and the associated entities we're going to manage with this unit. For those entity classes, we've got to identify the persistent storage for the managed entities. In other words, we're saying that these entities are going to be linked to those tables in that database, and then the persistence unit will ensure that that management takes place. We can also identify the transaction type we're going to use. We talked a little bit about transactions in the context of session beans last week. This is more about using transactions to manage database interaction. Now, the choices that we have are either to use the container managed transactions, or we can do it ourselves if we really want to, do it the hard way. We're going to use the container version of things in this module. Now, an entity is 100% Java. It's lightweight. A persistence domain object, in other words, it is an object that represents something from the problem domain, and it is linked to a table in the database. We do need to remember that although we've got an entity class, that class is representing one row. So we will instantiate that class, and each object will represent one row in a table. The persistent state of an entity is represented through persistent fields. You'll see what that means in a little bit. We can have persistent fields, we can have transient fields in our entities. So those that are persistent, those are the ones that are linked to specific columns in the relational database. Those that are marked as transient, well, they are not linked to a column in a table in a database. Instead, they're just used for holding data, and by annotating them as transient, it means that the persistence manager will not attempt to link them to some data in the table. We'll also see some annotations that are used to represent the various relationships between entities. Now, for an entity class to be an entity class, it must first be annotated as an entity class. It must have a public or protected default constructor, so no parameters. We could also use other constructors if we want to, but it must have a default constructor, along with set and get methods for each of the fields. That way, the JPA, Java Persistence API, can interact with it because it knows that it's going to have a default constructor with set and get methods for the persistent fields. A persistent field must not be public. That's not permitted in an entity class. And as I mentioned a few moments ago, it must have accessor and mutator methods and can also be accessed by business methods. I mentioned a few minutes ago about the idea of detaching entity objects. This means that we can then pass them around, but for us to be able to do that, we do have to ensure that we implement a java.io.serializable interface. We can put entities into an inheritance hierarchy as well if we want to. Let's take a quick look at a very small example. A customer has many accounts. So here we've got some SQL for creating database tables in Oracle. Create a table called customer with those columns. Create a table called account with those columns. And you can see that there is a foreign key that is set up. It is important that the relationships between the tables are correctly set up, because the entities that will be created from those tables will mirror those declared constraints, the relationships between the various tables. You can see that we have a constraint for a primary key in both. That's important. And that will also feature in the annotations in the entity classes. When the database has been set up, we'll have a database model, such as the one shown at the top of the screen, where we can see a one-to-many relationship between customer and account. When the entity classes are generated, we'll see that the object model is very similar, and the relationship is now represented as a collection of some sort. On the right, you can see a list of the attributes or the properties within each of these classes. And you can see that the account collection has been identified here in the little call-out box as being private. Remember, all those properties have got to be private. It's of type collection, and it's a collection of account objects. Those account objects are generated from the database table. So we've now got the two classes, customer and account, and in the customer class, there is a collection of account objects. And that's all done automatically when we generate it. If we were to look inside those classes a little bit more carefully, we would find, for example, a link to a column. So all the columns in the table will be represented in this way. See the annotation at column? That's the thing that links this particular property within the entity class to a column in the table. We're not obligated to call the property first name because the annotation tells us that whatever we call this variable, it's linked to the first name column in the table. But it makes good sense to call them the same thing since they're representing the same thing. Along with the declaration of the property, which is linked to a database table, there is a corresponding get and set method. We can, as I mentioned earlier, generate our own constructor methods. We're not limited to just a default constructor. Now, the important thing on this screen is the idea of primary keys. A database table has a primary key that will identify uniquely each row within the table. In this example, we're using a simple primary key. In other words, there is just one value or one column in the table that will serve as the primary key. And you can see at the bottom of the screen that in the Java code for the entity class, as well as the annotation to link this property to a column in the table, there's an additional annotation called ID. And that flags this property as being the primary key. Not all database tables have a simple primary key. And if we have a composite primary key, then we've got to do something a little more complicated. First of all, we need to write a class that will represent the columns in the primary key. So if you've got a primary key consisting of ent ID and other ID, being completely meaningless here, then we would have those two fields represented in this class. I'm calling it my composite key. Of course, you can call it whatever you want. That's not important as long as it's meaningful. And you have a default constructor method along with setter and getter methods. What we can then do is to prefix the entity class with an ID class annotation as shown here. So public class myEntity has been annotated as an entity and also has been given another annotation, the ID class annotation, along with myCompositeKey.class. So that tells the persistence manager that to represent the composite key, it needs to use an instance of myCompositeKey. As well as using that composite key class, we still have within the entity class the individual fields that link to those individual columns that form the composite key. The various relationships in the database model can be represented as aggregations of one sort or another in the object model, and in the implementation will be represented as collections of one type or another. And we'll use annotations to indicate what kind of relationship is being represented or is being implemented in that particular collection. Here's an example of the four that we have. So one-to-one, one-to-many, many-to-one, many-to-many. There's a corresponding annotation for each. In the customer class, which has a collection of many account objects, as well as having that declaration for the account collection, we find the annotation one-to-many and the column on which the join between those two is mapped. This means that the persistence unit will automatically load all the accounts that are related to a particular customer when that customer entity is loaded. So let's say customer 1 has got 3 accounts. When we cause customer 1 object to come into existence, the persistence manager will automatically also load the 3 account objects that are related to customer 1. But of course, this is a bidirectional relationship. So not only does the customer have an account collection, but the account also has a corresponding link back to the customer object to which it is related. And that's represented in the entity class with the annotation many to one. We've also got in there a join column. So if you compare the two sets of annotations, you can see that in the customer, the collection is mapped by cust ID, and in the account, the join column is identified as cust ID. Because we have a collection in customer, we would expect there to be add account and remove account, and that's fairly easy to do. Don't forget, any changes that we make when the object is attached to the database, any changes we make in that collection will be reflected in the database. So we can create an account object, add it into the collection in customer, and that will cause a corresponding row in the account table to be generated. This is all done by the entity manager, whose job is to manage those entity objects. Its type is shown here on screen, and it allows us to create and remove persistent objects, which will insert and delete rows in the corresponding tables. It will allow us to find entities using the queries, and also to update those objects, which the manager then will manage the update in the database tables. So now our Java code is a lot simpler in many ways, because we just have to use those objects as we would ordinarily use objects, and the persistence manager will take care of all that interaction with the database to make sure that there is consistency between our domain object model and the relational database model. Now, I mentioned that we're using container managed transactions. We're also using container managed entity managers. And all that means is that we will let the container decide when to create instances of the entity manager class. Typically, it will decide to instantiate one of these instances when it encounters an annotation that will cause some dependency injection to occur. So the only thing you've got to do in your Java class, once the persistence unit has been set up in your project, is to write these two lines at the bottom of the screen. Persistence context annotation, followed by a declaration of a variable of type entity manager. It doesn't have to be called EM, call it whatever you want. That's just a variable name to be used within your class. But it does need to be of type entity manager and have that persistence context annotation. What this means then is that when your class that has got this annotation in it is instantiated, the container will detect this annotation and will then look for an existing entity manager that can be used, and then just give you the reference. Put that reference in there. You never have to set that reference up. It's done automatically for you. Now, the Java Transaction Architecture, JTA, will allow us to make use of transactions to ensure that the database and the data model are always properly synchronized, that the data integrity is maintained, that we don't lose data or we don't get into inconsistent states. And this is very important when you're using a distributed model for your application. You might have different components on different computers. And so you don't want to have a change on one computer not be reflected on a different computer. You want those to stay in step. And if there's a problem in one, you don't want that problem to be propagated to the other. Or if there's a problem that causes data to be lost, or you've got to undo what you've already attempted, that also needs to be reflected in the other computer. And all of that really is managed through these transactions. And if we use the JTA, then that's done automatically for us. We don't have to manually put the code in there. And therefore, we will always use the container managed entity manager along with these JTA transactions. An entity object can be in one of four states. Let's assume that we haven't instantiated an object, an entity object just yet, so it doesn't exist. Then we have just an ordinary Java statement. Let's say the entity is called customer. Customer C equals new customer. Now, customer has been annotated as an entity. Therefore, this entity object will fall into the new state. It doesn't have a persistent identity yet. So we will put into the customer object that we've just created the various values that we want. It might be a customer name, address, telephone number, all of that sort of stuff that will go in there. We can use the set methods to do that. We could even do it with our custom constructor. We don't necessarily have to use the default constructor. Just create this object in the way that you would normally do it in your program. As yet, because it is in the new state, it is not linked to the database table at all. And it has no persistent identity. At some point, we will call a method in the entity manager that will cause this object to be persisted, which means that this object will now be associated with a row in the table. In other words, that row will be inserted. This is a new object, so it will be inserted into the table. And very importantly, the object will be given its persistent identity. So for example, if you've got in your database table auto-generation of ID values, the insertion of that row will cause an automatically generated ID within the database, and the manager, the persistence manager, will then use that ID in the ID field of the object that you created. It now is in the managed state. It is attached to the database, and any changes that you make to the object will automatically be reflected in the database table. Conversely, if you were to do some kind of manual SQL intervention on the database that changed the row that this object is attached to, then that object will be updated to reflect the new values. Or if some other component somewhere else in the application changes the database row that this object is attached to, then the object will automatically be updated. So there is always integrity of data between the object and the table row that it is representing. If we want to, we can detach these objects. Detaching them does not destroy them. It will maintain its persistent identity, but it is not linked anymore. It's not associated with the row in the table. So once we've detached it, if we were to change any of its values, the changes would occur in the object, but they would not occur in the database because it is detached. We can also remove the object, which basically means that that object is detached from the database and the row that it represents will be flagged for deletion. So those are the four states. Once we've removed the object, then the persistence manager will no longer manage it, and any changes that we make to it will not be reflected in the database. To set up a managed object, once we've created the instance, all we have to do is to invoke the persist method. Now that's in the entity manager. So we just call persist and pass that object as a parameter, and the manager will take care of all the rest of it. Now, if we were to persist a customer object that has got two account objects, then the cascading persist operation will occur. So not only will the customer object be attached to the database, but also the two account objects that are in its collection, they will also be attached to the database. And so we cascade down through the structure so that everything ends up being attached to the database. If the entity is already managed, when we call persist, that operation is ignored. If we have removed an entity and then call persist, well, then it will become managed again. So the row will once more appear in the database table. On the other hand, if we have detached an entity and try to persist it, then we've got a problem. Detached entities cannot be persisted, and therefore we will get an illegal argument exception, and most likely the commit will fail. More information is available in the official Java EE tutorial. There's lots more information available. We've just scratched the surface really, but it should be enough for you to do what you need to do in the tutorial task.